Hi, this is Venki. This lab is the ultrasonic sensor lab, and what I have here is a ultrasonic transmitter and receiver pair, and this ultrasonic sensor emits a 40 kilohertz wave towards that reflective surface, which then bounces back and hits that receiver. I have separate circuitry controlling both the receiver and the emitter. What the emitter does is it takes a PWM circuit and emits a burst of 40 kilohertz signals. I can show that to you on the screen. So okay, so what you see on the screen here is what the transmitter sees. So that little spike in the center is consists of a couple of square waves. I think it's around 6, and this is at a frequency of 40 kilohertz, which is what the ultrasonic sensor emits and receives it, and that then translates to a delay later on in the line. So if there is a short distance, it doesn't take that much time, but if the distance is much longer, like if the box is down here, it takes a lot longer to actually come back, and so you see it takes some time to actually see the sensor again. Let me connect this back up. You can see what I'm talking about. So over here, I'm kind of displaying two things, sorry. So this is the converted signal. I've done some signal processing and generated a signal. This front end represents a static point in time, and this edge represents the distance of the sensor of this box. So as you can see, I vary the box. That thing also varies, and this can happen up all the way up until here, which is about 5 feet, which corresponds to that length, and it decreases accordingly. This is quite reliable and accurate, and as you can see, it's pretty steady. There are some minor fluctuations, but it's pretty good. So this signal is converted from this raw signal over here. So you can see there's barely anything. This is some, if I quickly zoom into that portion. So initially you see this kind of noise, which I've handled using separate circuitry, which can be seen in my schematic. I've basically turned off any receiving point for this, like any analog switch kind of, and for the other end you can see there's not much to work with. So all there is like this little blip over there. It's barely even noticeable. If I move it, you can see it much more clearly. Yeah. So the bump there corresponds to that. So that's what was really video processing. So you've been hearing this buzzer in the background. So basically what this buzzer does is it acts as a kind of alarm for it's like a proximity buzzer. So if this comes within a certain distance of the receiver, it generates that noise. So you can see if I mark the distance, yeah, and it stays buzzing throughout this whole sine range, and it stops buzzing there. So right about here, there's a couple of inches of leeway, but right about there, it stops buzzing. It starts and stops buzzing. So anything beyond this point, it will not buzz, and here onwards, it will buzz. So this point is actually adjustable, and it's adjustable via a push button, which is right there in the center of this thing. So there's a push button there, and if I set it, there will be an LED flash confirming that I've set the voltage, and then the new set point will change. So let's see that in action. So let's say I want the set point to be there. I put the set point, I click the button, I get a flash, and it's already buzzing because it's within this range. Let's move this here, move it out, everything's good. If I move it back in, once again starts buzzing.